Good evening, one and all present here. Today, I'll be seeing in detail about different types of solid state fermentation and fermentation types. And what is fermentation? Fermentation is a metabolic process that produces chemical changes in organic substrates through the action of enzymes. There are three types of fermentation: batch, continuous, and fed batch process, in which this comes under submerged fermentation. So basically, based on the substrate used, it can be classified into submerged and solid state fermentation. So based on the process, it has been classified into batch, fed batch, and continuous. So batch system is a closed system. Fed batch is a semi-batch, that is semi-continuous system. That is, the feed will be given in a batch-wise manner, and continuously the product will be taken on. And whenever the inoculum is depleted of nutrients, again in a batch, the inoculum, the substrate will be transferred. And continuous is an open system, that is, the feed will be given continuously and the product will be taken out continuously. So these are the different types of batch for continuous fermentation, the fed batch processes. And types of fermentation based on the substrate used, can be classified into solid state fermentation and submerged fermentation. And these are the advantages and disadvantages of solid state and submerged fermentation. So in short, the submerged fermentation is nothing but it can be a batch or continuous process, but the solid state fermentation is only a batch process. That is, organisms which require very less moisture content or no moisture content can grow in a solid state fermentation, whereas submerged fermentation is full of water. That is, the inoculum will be in a liquid form. Here the inoculum is sprayed on the surface of a solid support. So in the case of submerged fermentation, we have aeration and agitation system using sparger and impeller. But in the case of solid state fermentation, no aeration is aeration is carried out by passing sterilite, but there is no agitation. So since there is no agitation, no foaming also present. But in the case of submerged fermentation, there will be foaming. And power consumption is very high in the case of submerged fermentation, and all the process is automated in submerged fermentation. But in the case of solid state, the power consumption is low and automation cannot work out in solid state fermentation. And these are the important features. Some of the important features of solid state fermentation is usually the fermentation, that is, the microorganisms which require very less moisture, that is, filamentous fungi, can grow very well in solid state fermentation process. And large production of mushroom or any commercially important enzymes which are produced by organisms which do not require much moisture content can be grown in solid state fermentation process. And this is the typical pictorial representation of solid state fermenter, in which we have a mini reactor through which air is being passed out, and we have air supply, but there is no agitation, and the entire product will be delivered in an empty bottle. So this is the support, or the solid support, in which the microorganisms are being grown. So this is the detailed view here, which we have many trays in which the solid support like wheat bran or any husk or will be present, in which the microorganisms will be grown. To facilitate the temperature, to maintain the temperature, cooling coils will be present, in which we will be circulating the cooling water. And factors involved in solid state fermentation process, as usual, we have to select the microorganisms which do not require water for their growth, and substrate which produces a solid substrate, that is, it produces all kinds of nutrients for the growth of the organism. And process optimization and product isolation and purification is also very tougher when compared to submerged fermentation. And some of the applications, it is used in the production of proteases, cellulases, lignases, xylanases, pectinases. And in the case of biopesticides, baseless through protein can be produced in large scale to prevent the attack of pests in the case of BT cotton. And what are the applications? It's used in food industry, agriculture, and industrial fermentation. In the case of food industry, large scale production of mushroom, bioconversion of any products, food additives can be produced. In the case of agriculture, biopesticides, biocontrol, and bioinsecticides are produced in large quantity. And the submerged fermentation is nothing but it is a batch process in which the liquid it is a batch or continuous process in which the normal bioreactor, in which we have the batch, continuous, or fed batch fermentation process. The organisms are being supplied in the form of liquid form, and agitation and aeration will be taken, but the purification step is simpler, since this process is very sterile and this kind of process is used for the extraction of secondary metabolites from microorganisms, which is usually in the liquid form. And this is the pictorial representation of a submerged fermenter in which the media is prepared and the media will be sterilized, and we will have an automated bioprocess control unit in which the pH, temperature and other process parameters are maintained, and we have inoculum preparation and preparatory pilot scale fermenter, and the inoculum is fed into it, and after the fermentation the cell will be recovered. Product recovery will be taking place by downstream processing technique, and water treatment and disposal will be taking place. So these are the majorly in many industries, submerged fermentation is used because the accumulation of variety of intermediate metabolites results in lowered enzyme activity and production efficiency. So we need to have a very purified product. So we need to follow the stringent downstream processing techniques to extract our desired product of interest. Thank you.